Hello. So we're looking again at graphing of linear equations, and we last week looked at graphing lines by completing a table where we'd fill in the table for x and y, and then we draw the line. We also talked about using the graphing calculator, but there's some things that I need to go over so that you can do them by hand. So we're going to talk about graphing using intercepts. So an x-intercept is the place where a line will cross the x-axis, and a y-intercept is the place where it crosses the y-axis. So the x-intercept in this picture is at 3, or at 3, 0. You could give both coordinates. And the y-intercept is at 2 units up, or at 0, 2. Now, to find intercepts algebraically, you can set the opposite letter, the opposite variable, equal to 0. So if you're looking for the x-intercept, we're going to set y equal to 0. So you have this equation, y equals 4x minus 6, and you're going to set y to 0 if you're finding the x-intercept. So you have 0 equals 4x minus 6. And then you're going to add 6 to both sides to move that 6 over. So you have 6 equals 4x. And then you divide by 4. And you get 6 over 4 equals 3 over 2, or 1.5. So 1.5 is the x-intercept, as you see in this picture. 1.5 is where it crosses the x-axis. Now, if you set x equal to 0 in the equation, so you have 4 times 0 minus 6, well, that, of course, gives you negative 6. So the y-intercept is at negative 6 right here. And as soon as you plot those intercepts, then you can draw the line, and you've got the line graphed. Here's another example. If you have y equals negative 3/5 x plus 4, if you're looking for the x-intercept, you can set y equal to 0 again, and that gives you this. Now, I would move the 4 over by subtracting 4 from both sides, so we get negative 4 equals negative 3/5 x. Now, to get rid of this fraction, I would recommend that you multiply by the reciprocal on both sides. So just flip over the fraction, so the reciprocal of negative 3/5 would be negative 5 over 3. That's all you do, just flip it over. And so I've got negative 5 over 3 multiplied on the left side, and negative 5 over 3 multiplied on the right side. Now, what happens on the right side is the numbers all cancel. First of all, negative times a negative would make it positive, and then the 3's cancel and the 5's cancel, so you basically have positive 1x, or just x on the right side. On the left side, you have negative 5 times negative 4. You multiply that, you get positive 20. On the bottom, you have 3 times 1, so you get 3 on the bottom. So 20 divided by 3 is 6 2/3. If 3 goes into 26 times with a remainder of 2, so it's 6 2/3 is your x-intercept. The y-intercept is, well, you plug in 0 for x. Negative 3/5 times 0 is just 0, plus 4 is 4. So y equals 4 is your y-intercept. So I plotted the y-intercept here at 4, and the x-intercept at 6 2/3. If you move over 6 and then another 2/3 of the way going towards 7, that's where 6 2/3 would be located. And so then you can draw the line passing through those two intercepts, and you have the equation graphed. Now, just to make sure that the concepts are clear, here's a few more notes on intercepts. So the x-intercept is the place where it crosses the x-axis, so it's pictured here. The y-intercept is the place where it crosses the y-axis. In order to find this, if you're given an equation, if it's an x-intercept, you're going to set y to 0 and then solve for x. If it's a y-intercept, you'll set x equal to 0 and solve for y. So here's another example. You plug in to find the x-intercept, you're going to plug in 0 for the y, and you get 0 equals 2x minus 3. Move the 3 over, divide by 2, you get 1.5 again. For the y-intercept, we're going to just set x to 0, so you get 2 times 0 minus 3, so that would be minus 3. So negative 3 is your y-intercept value, and 1.5 was the x-intercept. So it doesn't really match this picture, but that's how to find those intercepts. Now when you have a horizontal line like y equals 1, you can think about a table where y is always 1. It does not have an x-intercept because x can never be 0 because y can never be 0 because y is always equal to 1. And so 0, 1 is the y-intercept right here. I should have an arrow pointing at the y-intercept right there, but there's no x-intercept. All right. Another example, y equals 3/4 x plus 2. All right. To find the x-intercept, let's set y to 0. And I do that over here. So 0 equals 3/4 x plus 2. I would subtract 2 from both sides to move that plus 2 over, so it becomes negative 2 equals 3/4 x. Then I would just multiply both sides by the reciprocal, which is 4 over 3. And so I go 4/3 times negative 2. Well, multiply 4 times negative 2, you get negative 8 over the 3. And on the right side, the 4's cancel and the 3's cancel, so you just get x. So x is negative 8 over 3. That's the x-intercept, excuse me. The y-intercept, well, just set x to 0, so you have 3/4 times 0 plus 2, and that gives you 2 for the y-intercept. Now, when you get into Math 130 or other math classes, they might have more than one intercept. Like in this picture, there's actually 3 x-intercepts. It crosses at negative 5. You can't see the scale on this, but let's suppose it crosses at negative 5, at negative 1, and at positive 4. So there's actually 3 x-intercepts, and it's a y-intercept of about 1.5 there. So it's just an example of multiple intercepts. Now, slope is a very important concept, one that you really need to understand. Slope is not dependent on your starting point. You could start anywhere, but it's dependent on how much you change in the y direction, that's up and down, divided by how much you change in the x direction, which is usually called the run. So it's rise over run. So in this diagram here, you see that from point A to point B, we rose up 1 unit and we ran 2 units. So the slope would be 1 over 2, a rise of 1 and a run of 2. From point B to point C, I guess you can't see the letter. This is supposed to be labeled C here in the upper right corner of this diagram. So from point B to point C, you're going to rise up 2 and run 4. And if you notice, 2 over 4, that also equals 1/2. And then what if we went from A all the way to C? Going from A all the way to C. Well, it's a rise of 3 units, up 1, 2, 3 units, and a run of 6 units, so it's 3 over 6. Now that's also equal to 1/2. So the point is, any 2 points can be used to determine the slope of a line. It doesn't matter. You always get that same slope no matter what 2 points you used for that line. Now I would choose points that are right on the whole numbers, so you don't have to deal with the fractions and decimals. Okay? Now, let's say you're given a graph like this pictured right here, and you want to find the slope. Well, start at 1 point. So I started at this point on the left here, and I want to go to the point on the right. So it's going down 2, so we have actually a negative rise. It's not a positive. A positive rise would be up. A negative rise would be down. So it'd be down 2, so -2 for the rise, and it's running 3 units to the right. So the slope would be -2/3 in this picture here. Okay. In the second picture right here, again, rise over run. Now, again, it doesn't matter where you start. What matters is how much you rose and how much you ran. So in this picture, we're starting at -1, -1, but we're rising up 1, 2, 3 units. Or you could start from the level of -1 and rise up here 1, 2, 3 units. So your rise is 3. Your run would be 1, 2, 3, 4, 5, 6. So from -1 to +5 is a run of +6. So the rise over the run is 3 over 6, or 1/2 in this picture. Now, in a horizontal line, it doesn't have any rise. A horizontal line is not rising at all. So it's a 0 rise over whatever the run is. In this case, it was a run of 3. All right, so the slope of a horizontal line is 0. And you would guess, okay, what's the slope of a vertical line? Well, you have a rise. So in this picture, you see a rise of 2 units. But what you don't have is a run. It doesn't move anything to the left or the right because it's a straight vertical line. And so the run is 0. And if you divide 2 by 0 with a calculator, you're going to get an error. So we call it undefined. So we say that the slope of a vertical line is undefined. So when you have a graph, you can visually see and count the rise and the run. But if you have no graph, but instead you just have the coordinates of 2 points, then we would use what's called the slope formula. So the slope formula says m, the slope, the magnitude of the slope, is y2 minus y1 over x2 minus x1. Now these numbers in the formula are subscripts. Subscripts just denote which one you're talking about. So this means the y-coordinate for the second point minus the y-coordinate for the first point over the x-coordinate for the second point minus the x-coordinate of the first point. Now when you do that, you subtract the y values, you're really finding the rise, because the y values tell you the height of a point, and when you subtract them, you find out the rise, or the change in the y values. And when you subtract the x values, that's finding the run between those 2 points. So I've labeled the points x1, y1, so 3, 2 are the x1 and the y1, and -1, 4 are the x2 and the y2. So you don't do anything with those subscripts except help you identify which point you're talking about. All right, so now we'll plug those numbers into the formula. So y2, well, y2 was 4. 4 minus y1, well, y1 is 2, so we have 4 minus 2 in the numerator. In the denominator, we have x2, which is -1, minus x1, which is 3. So -1 minus 3, that's -4. And so you have the fraction 2 over -4, or -1/2 is how that reduces. -1/2. All right. Another example, if you have -4, -1, and -2, 5. Okay, so the y2, we start the formula with y2 minus y1. So the y2 is 5 minus y1. Now, y1 is a negative, so we're going to have 5 minus -1. And when you have a minus, of course, that's just plus. So I changed the 5 minus -1 to just 5 plus 1 in the numerator. In the bottom, you have x2, which is -2, minus -4, which is your x1. So -2 minus -4. Now what happens? Well, the minus -4 becomes plus 4. So you have -2 plus 4, which equals +2. So you have 6 over 2 or 3. So the slope is 3. Okay? Now, if you want, you could have plotted those points, and you could have counted the rise and the run on the graph, and you should end up with 3 over 1 or 3 when it's reduced. Okay? Now in the next example, we have y2, which is negative 2, minus y1, which is negative 7. So negative 2 minus negative 7. Of course, that becomes negative 2 plus 7, or 5. And on the x's, x2 minus x1, that would be 3 minus 3. Well, 3 minus 3 is 0. And if you have 0 on the bottom, you cannot divide it. So you get undefined. Whenever you have 0 on the bottom, it's undefined. Okay? So that's how to use the slope formula to find the slope. But as in most things in math, when there's a process or a formula, you've got to practice that process. Now, you've probably realized that if two lines have the same slope or steepness, slope measures the steepness that the line is going up or down, if it's a negative slope. So if the steepness of two lines is the same, then they're going to be parallel lines. And so parallel lines will have equal slope values, equal slopes. So in this problem, you see two lines that both have the slope of 1/4. And so they're going to be parallel. Okay? Now perpendicular lines have slopes that are opposite reciprocals. And so if one slope was 1/2, for example, and the other slope was negative 2 over 1, 1/2 and negative 2 over 1 are opposite reciprocals. And so they would be perpendicular lines. So another example here, if a slope has, a line has slope negative 2 over 5, a line that's perpendicular to it would have the slope of 5 over 2. Now notice, you both flip it and negate it. So when you negate a negative, it becomes positive. So they have to be opposite signs and flipped compared to each other. Okay, that's opposite reciprocals. And if that's the case, then the two lines are going to be perpendicular to each other. So here's another example. What is the slope of a line that is perpendicular to a line with slope 3? Well, 3 is 3 over 1. And if you flip 3 over 1, you get 1/3. And you got to put a negative sign on it because you got to change the sign. It's flipping and negating. So flip it, I get 1/3. Put a negative sign on it. So negative 1/3 is the answer. Now, slope has real-life applications, and mainly slope is a rate of change of one variable in comparison to the other variable. Okay, that's what slope, the significance of slope is in taking algebra and applying it to the real world. So here's an example of that. Let's suppose that the profit of a business started off at 500,000 in the year 2000, and it ended up to be 1,500,000 in 2008. What is the rate of increase? Now in the graph, instead of putting writing it in thousands, I'm sorry, in single dollars, so I'd have to write 500,000, 1 million, 1,500,000. I just made my graph scale go in thousands. So 500,000s, 1,000 thousands, which would be the same as a million, and 1,500 thousands, which is the same as 1.5 million. So anyway, the starting profit was 500,000. So at 0 in the year 2000, I'm calling the year 2000 0. It was started at a height of 500,000, or 500 in this graph. After 8 years, I don't have a number 8 over here, but you can see it's going, 2, 4, 6, 8. So in 2008, which is right here at the end, it's up at 1,500,000 or 1,500 thousands. And so I've drawn my second dot, and then I drew the line passing through them. Now, the slope is the rise over the run, and you could subtract the y values, 1,500 minus 500, and you get 1,000 thousandths, which is 1,000. I'm sorry, 1,000, but we're talking in thousands, so it would really be a million. And then divided by 2008 minus 2000, which is 8. So 1,000 over 8, and if you divide that, you get 125 over 1, or 125. And so what this is saying is that the rate of change each year is 125,000, because we're talking in thousands here, per year. Okay, so that means the profit of the business is rising by 125,000 every year. Okay. Another example. Suppose you order 20 shirts for your company, and it costs, after shipping, $216. Then suppose again you order 36 shirts, and it costs, after shipping, $360. Use the change in Y over change in X definition to find the price of a single shirt. Okay. Now the rate of change, it's changing in cost. 360 minus 216 would be the change in the cost. So you take the second one, 360 minus 216, the first one, and you get the change. That's $144. But how much was the change in the number of shirts? Well, the second time around there's 36 shirts, and the first time around is 20. So 36 minus 20, that is 16 shirts. So we've upped our order from 20 shirts to 36 shirts, which is 16 shirts higher. And it cost us $144 more. So if you divide 144 by 16, it equals 9 over 1, or 9, which means it's $9 per shirt. So that's the answer for the rate of change. So I said find the price of a single shirt, and we did, $9 per shirt. Now another side question is, if a shirt costs $9 each, how much is shipping? Well, you could multiply 20 times 9, and that would give you how much money you're paying for the shirts. 20 times 9 is 180. 180 is how much you're paying for the shirts, but you had to pay $216 for that shipment. So how much did you pay for shipping? Well, $216 minus the 180 for the shirts, and you get $36. So it's $36 for the shipping for the shirts. All right, so here's another example. In a cell phone company, charges $48 for a month, in which you use 400 minutes, and $54.75 for a month in which you used 550 minutes. Find the following. How much do you pay for each minute you use? All right. Well, you could find the change in the Y, change in the cost, and divide it by the change in the number of minutes. And that would be the rate per minute. So if you take 54.75 and subtract 48. All right, so I went ahead and worked out the you try it problem. So in letter A, it says, how much do you pay for each minute you use? Well, if your bill for 400 minutes was $48 and your bill for 550 minutes was $54.75, if you subtract the change in the bill, you get $6.75, and if you subtract the change in the minutes, it's $150. So for $6.75 more, you're getting 150 minutes more. And so the rate of change of cost to minutes is 6.75 divided by 150, which comes out to 0.045 cents. So it's like 44.5 cents per minute, $0.045 or 4.5 cents per minute. Okay. Now, I also asked the question here, what other monthly charge do you have? So there's the cost for the minutes, and then there's the monthly service fees. And so the minutes charge, if you know, what do you charge for the minutes? Well, it would be the rate 0.045 times the 400 minutes, but that only comes to $18. So your total bill was $48. So if you subtract 48 minus 18, you get $30. So $30 is your plan fee or your you know, administrative costs, while the minutes fee is, you know, 4.5 cents per minute. All right. So one of the most useful forms in dealing with lines is called the SlopeIntercept Form. And here it is at the top of the page. Y equals mx plus b. M is the slope. B is what we call the y-intercept. You know, sometimes the x-intercept is called A, and in this situation, the y-intercept is called B. Anyway, so SlopeIntercept Form has a lot of benefits if you can get, you know, learning how to use it. You're not familiar with it. So here's an example. Suppose we have the equation y equals 1/4 x plus 1. Now that is in the form, the SlopeIntercept form. You got to start with y. So y equals should be at the beginning of the equation. And then you'll have some fraction or whole number possibly in front of x. So that's the m. So 1/4 x. And then at the end plus b. So b must be 1 here. So that means you're going to have a slope of 1/4, 1/4, and a y-intercept of 1. So you're going to go rise up 1, and that's your y-intercept, the place where it crosses the y-axis. And then your slope is 1/4, meaning we're going to rise up 1 and run 4. Or you could do the run first and then the rise. Doesn't matter. You're going to end up at the same point anyway. So you start at the y-intercept. That's your first point. And then you move whatever the slope, the rise and the run of the slope tell you to get to the second point. So once you have the 2 points plotted, then you can draw the line passing through them. Here's another example. Y equals -2/3 x plus 4. All right, well, start at the y-intercept, which is 4. And then we're going to do the slope, which is down 2 to the right 3. So down 2 to the right 3. And it mentions it right here. Once you get those 2 points drawn, you draw your line through the 2 points. Now, if you have y equals -2, well, that's a horizontal line. But you could think of it as y equals 0x plus -2, because 0x, that's just going to disappear and give you just y equals -2, which is what we started with. So that means that the slope must be 0, and it crosses the y-axis at -2. So starting at -2, make a line that has slope of 0. So in other words, a horizontal line. Another example, y equals 2x. This is as if you had a 0 at the end of it. In other words, the b is 0. So y equals 2/1x plus 0 is the same thing. And so our y-intercept is 0, so it crosses here at 0, and then it has a slope of 2/1. So that's what I did. I went up 2/1. Up 2/1. That's when the slope is 2, or 2/1. And so I could graph the line. Now, we talked about slope-intercept form. And so let's talk about how do you get an equation into slope-intercept form. So this is called converting from general form into slope-intercept form. So general form is ax plus by equals c. It's where both the x term and the y term are on the left side, and the c, or the number, the plain number, is on the right side. So here's an example: 4x plus 2y equals 10. So here A is 4 and B is 2 and C is 10. But all you have to do to get it into slope-intercept form is solve for y. Solve for y. So I'm going to move everything over to the right side except for the y term. So I first subtract 4x from both sides. So I get negative 4x plus 10. Now get into a habit of putting that x term first and then any plain number at the end. So now we just have to get rid of the 2. So I'm going to divide 2 by everything, or divide everything by 2. And so 2 divided by 2 gives you just y, or 1y. Negative 4 divided by 2 is negative 2. And then 10 divided by 2 is 5. So now we have this equation in slope-intercept form. And the slope would be negative 2 over 1, or negative 2. And the y-intercept would be 5. So I would graph it by locating 5. I would go up to 5 on the y-axis, because it's a y-intercept of 5. And then go from there and do the slope. The slope tells you to go down 2 to the right 1. So down 2 to the right 1. Now I went to the right 1, then down 2. But it doesn't matter. Same thing. Down 2, right 1 would end you up at the same point. So the point 1, 3 is on the line, we believe, and 2, 1, which is this point right here, is on the line. And if you plug them in to the original equation, you can see that both equal 10 on the left side, equals 10 on the right side. And so it verifies that our equation that we graph using the slope-intercept form is really the same line as the original problem. All right. So in this next one, we have x plus 3y equals 0. So this is weird because you don't have a c, a number on the end. All right. So we again move the x to the right. We're trying to solve for y. And so we get 3y equals negative x. And I just divide by 3. Now I can write that negative x as negative 1x, and then I divide it by 3, so it's negative 1 over 3 for my slope times x. So I divided by 3 on both sides, and I put a 1 in front of that negative 1. So negative 1 over 3, and so that's your equation. Now how would I graph this? Well, the y-intercept is 0. Remember, it doesn't have a number on the end of the equation. It's just mx instead of mx plus b. So we're going to start at 0, and we're going to go down 1 to the right 3. So down 1 to the right 3. It ends up right there, and you draw the line, and you have a line. And then you can test the point. Now I took the test point of 3, negative 1. 3 to the right, down 1, and I plugged it into the original equation, and it was correct. It worked out on both sides. Okay, so far we have had problems involving linear equations and lines where you were always given the linear equation. So now this last part is about how do you find the equations if you're given certain things. So how do you come about figuring out what the equation is? So the first type of problem like this will be a type where you're given the graph. So here's an example on the right side here. So the steps: first, determine the y-intercept. So the y-intercept is the place where it crosses the y-axis, the vertical axis. And you can see that this crosses at negative 2. So that's the b, which is what we call the y-intercept. So b would be negative 2. the y-intercept. Now from that point, you can see that to get to this other point over here, it had to rise up 2 and run 3. So the rise was 2 and the run was 3, so the slope must be 2 over 3. So whenever you're given a graph and you have 2 points, you can do the rise and the run between the points and figure out what the slope is. Now the slope is the m in the y equals mx plus b equation. So now that we have the slope and we have the y-intercept, which is the b, we can plug in these two values into the slope-intercept form, y equals mx plus b. So it would be y equals 2/3 x and then plus -2. But plus -2 is the same as just -2. It's still, the 2 is negative. So you could say plus -2 or just -2. And there's your equation of the line. All right. Now in this next picture, you have a y-intercept of +3. You can see that it crosses the y-axis at +3. And then from there, it goes down 2 and to the right 1. So the rise is -2 and the run is 1. So the slope then is -2 over 1. And so that's where I got slope is -2 over 1 or -2. So if the slope is -2, I can just plug that right into the location where the m goes. So y equals -2x plus 3. All right. Now there are some special types. You have if you have a vertical line, the equation is going to be x equals whatever the x-intercept is. So the x-intercept in this problem, you can see, is 2. It crosses the x-axis at 2. So the equation, if it's a vertical line, will just be x equals wherever it crosses the x-axis. So it would be x equals 2, and that's your equation. You're done. You don't have to do anything. If it's a horizontal line, now here's your y-axis, I'm sorry, your x-axis. It's raised up 1 unit, so it's at a height of 1. So the y values are all 1. So the equation is y equals 1 in this problem, because it's a horizontal line passing through 1 on the y-axis. In this last example on the bottom right, you can tell that it crosses through 0, 0. So the y-intercept must be 0. And then if you figure out the slope, well, it's rising 3 units, 1, 2, 3, and running 2 units. Rising 3, running 2. Up 3 over 2. So the slope is 3 over 2. And so you plug those into the formula. You have y equals mx plus b. So y equals m, which is 3 over 2x, plus 0. Now you don't need to write plus 0, so the equation is just y equals 3 over 2x. And then another situation, we'll find an equation using a new formula, Pointslope Formula. And this is used when you know a point on the line and the slope of the line. You've got to know those two things to use this formula. So the Pointslope Formula is, now we're assuming that the name of, we're calling the point x1, y1. We're just naming the x and the y coordinates x1, y1. So x1 is a specific x value for that first point, and the y1 is the specific y value for the first point. So the formula is y minus y1, where y is that specific y coordinate, equals m times parentheses x minus x1. So let's see how to use this. So if you're given a problem, find the equation of the line with slope 3 over 2 passing through the point 4, 5. Okay, so 4 is the x1, 5 is the y1, and the slope, your m value, is 3 over 2. So I'm going to plug all those in. So y minus y1, now y1 was 5, so y minus 5 equals m, the slope, 3 over 2, times parentheses x minus x1. x1 is 4 here. So then you distribute the 3 over 2 times x and 3 over 2 times negative 4. Now I didn't show how I got negative 6 here when I multiply 3 over 2 times negative 4. But if you go off on your paper somewhere and write 3 over 2 times negative 4, I would put the negative 4 over 1. So we have 3 over 2 times negative 4 over 1. Then you can multiply the tops together, so you'd have 3 times negative 4, you get negative 12. And on the bottoms, you have 2 times 1, so that's just 2. So if you have negative 12 divided by 2, you get negative 6. So that's how I got the negative 6 there. And then I would just add a 5 to both sides to get the 5 moved over. So negative 5 added with the 5 just disappears, so you get just y on the left side. And then if I add negative 6 and 5, I get negative 1. So I get the equation y equals 3 over 2x minus 1. That is the equation of the line that has slope 3 over 2 and passes through the point 4, 5. Now, if you don't believe us, you can plug 4 and 5 into that equation, 4 for x and 5 for y, and you'll see that the left side equals the right side. So it'll work out. That's the slope-intercept form of the line. Now, in the next example, it says find the equation of line through the point 3, negative 1, with slope negative 1 over 5. So I'm going to plug in 3 for the x1, so I put it right here, and negative 1 I'm going to put in for the y1. And notice we have y minus negative 1 because the formula says y minus y1. So y minus negative 1, and that's going to just end up to be y plus 1, of course. And then you have the slope, m, negative 1/5, times x minus 3. You would distribute, and you'd get negative 1 over 5x. And if I multiply negative 1 over 5 times negative 3, I get positive 3 over 5. Now, I need to get rid of this plus 1 on the left side. So I would subtract 1 from both sides. So that would give us just y. And so what do you do on the right side where you have this 3/5 minus 1? Well, you could get a common denominator and change the 1, or negative 1, into negative 5 over 5. And so that's what I did here. So the left side is just y, and on the right side it's equal negative 1/5 x. And then we have 3/5 minus 1, which is 5/5. So if I have 3/5 minus 5/5, I get negative 2/5. So the equation is y equals negative 1 over 5x minus 2/5. Now, I can get rid of the fractions if I multiply everything by 5. So if I multiplied everything by 5, I'd have 5y equals negative 1x, because the 5s will cancel, minus 2, because the 5s will cancel. And so you get this equation, and then if you move the x to the left, you'll get positive x plus 5y equals negative 2. And that's the general form for the equation that is this for this line. Okay, now the slope-intercept form was right above it here. Y equals negative 1/5 x minus 2/5. Sometimes you do get the y-intercept, the b, to be a fraction, but in this case we multiplied through by 5 and got rid of the fractions. Now a third way to find the equation of a line is used when you know just 2 points. So like here, if you know 2 points, so what if I know negative 3, 1, and 0, 7? Well, this method is really the same as the last method, but first you find the slope. And then once you have the slope, you've got a point and you've got the slope, so you can use the point-slope form. Okay, so here's your points, -3, 1, and 0, 7. So I'm going to do y2, which is 7, minus y1, which is 1, over x2, which is 0, minus -3. So 0 minus -3, of course, that becomes just 0 plus 3, or 3. And so 7 minus 1 is 6, over 0 plus 3, which is 3. So 6 over 3 is 2. All right? So the slope came out to 2. And then I plugged that slope in here into the point slope form. And I chose to use 0, 7 as my x1, y1. It doesn't matter which one is you use your x1, y1. So it's y minus the y1, which is 7, equals 2 times parentheses x minus 0, which is your x1. And then you distribute the 2, so you basically have 2x. So y minus 7 equals 2x, and then I would add a 7 to both sides, so I get y equals 2x plus 7. And you can check that out. You could plug -3, 1 into it and see if it equals on both sides. All right. Now here's some more examples. You go ahead and try to work them to find the equations, and then I'll come back with the solutions on there. And I'll talk to you about how I did those. All right, so if you've tried these problems, I'm going to show you or explain how I got the answers. So we had to find the equation of a line with slope 2 passing through 0, -6. Now, if the slope is 2, then m is 2. And since 0, -6 is on the y-axis, it's 6 units down on the y-axis, so that's the y-intercept. So b would be -6, and that's the y-intercept. So the equation then is easy. You can just go y equals 2x minus 6. So in that case, it was just a matter of realizing that the -6 was the b, and we had the slope, so just plug it into the equation. In b, you're given the slope is 2/3, and you're given a point on the line, -6, 5. So we can use the point-slope formula. So it'd be y minus the y-coordinate of the point that we have, which is 5, and then equals the slope, 2/3, times x minus the x-coordinate. Now the x-coordinate of the point is -6, so you're going to have x minus -6. So you have that double negative, which of course becomes plus 6. So it's y minus 5 equals 2/3 times x plus 6. And then we distribute the 2/3. So 2/3 times x is 2/3 x. 2/3 times 6 is 4. Now that's another one. You're going to have to go off to the side and go 2/3 times 6 over 1. And if I multiply the 2 times the 6, I get 12. And then 12 divided by 3 times 1 is 3. So 12 divided by 3 gives you 4. So that's how I got the 4 there. So then I just add 5 to both sides to move that 5 over. So I have y equals 2/3 x plus 9. In the third example, find the equation of a line passing through the points 2, 5, and 6, -15. All right, so first of all, you need to find the slope. So I used the slope formula, which was the same thing I did up here at the top of the slide here. So I want to do the y2 minus y1, so -15 minus 5. So that's how I got that. That's in the numerator. Divided by, I just put a backslash here for numerator divided by the denominator. And then the denominator, I'm going to have x2 minus x1. So 6 minus 2, which gives you 4. And so we have -15 minus 5, which is -20, divided by 4. That's -5. So we got a integer anyway, -5 for the slope. And then I'm going to use the point 2, 5. Now I could have used 6, -15, but it's easier to use the smaller numbers, 2, 5, as my x1, y1. And then I plug those into the formula. So I had y minus the y coordinate, which is 5, equals m, which was negative 5 that I found already, times parentheses x minus 2. So that's the equation. Now I'll just simplify it. I want to go ahead and distribute. So if I distribute, I get y minus 5 on the left side, but negative 5x plus 10 on the right side. And then if I add a 5 to both sides, I'll get y equals negative 5x plus 15. So that's the equation, negative 5x plus 15. And I would always, as a student, I would always test my solutions. I would plug the 2 in and 5 for the y and see if that works. And then also plug in 6 and negative 15 for x and y and see if that works. If you have checked and it works for both pairs of points, you should be 100% sure that you've got the correct equation for that line. Okay? So you don't, there's no guessing around. You can be 100% sure. All right. So that's all. Let me know if you have any questions.